Okay, so we're beginning chapter 1, section 1, and we've read on page 2 and 3. Really, the only thing on page 2 that I want to make sure that we hammer home, you should already know what a Cartesian plane is. You should know the x-axis and the y-axis. But the one thing that sometimes people forget is the naming of the quadrants. So remember, that first quadrant up here is the first quadrant. We use a Roman numeral to show it's the first quadrant. And then we rotate counterclockwise from there. So here's quadrant 2, 3, and 4. Like so. So make sure you know how to name them and the order in which we name them. Okay, now we're on page 4. We are going to skip example 1 for now. You have to use a graphing calculator to do that. We'll come back to that at the end of the section. But we're going to do the graphing calculator stuff at the very end. So the first thing I want to do is I want to look at example 2, which is finding distance between 2 points. So it tells us to find the distance between the 2 points 1, 3, and 5, 6. So let me get my Cartesian plane in here. There it is. Now, we may already know the distance formula and how it works and how to plug into it, but we're going to assume right now that we don't know the distance formula, and we're going to try to come up with a different way to find the distance between those 2 points. Okay, so what I'm going to do first, I'm going to graph the 2 points. So first we graph 1, 3, which means I'm going to go right 1, I'm going to go up 3, and that point is right there. Then I'm also going to graph 5, 6. Right 5, and up 6. And there's my other point. So everybody good? We've been able to graph points. All right. The x is listed first, y is listed second. Now, how could I find the distance here? Well, the distance would be the value represented by that red line. Right? It's how far is it between the 2 points. But the way we're going to find it is we're going to use our rise and our run. We're going to find 2 sides, straight vertical and straight horizontal. So first, let's see how far vertical must we go to get on an even plane, and then how far horizontal do we have to go. Now, what is formed when I do that? I have formed a right triangle. Anytime you ever use rise and run like that, you will form a right triangle. And so what we're going to do is use the Pythagorean theorem, which says a squared plus b squared equals c squared. And just remember that the c must be the hypotenuse, which is represented in red here. Okay? So we don't know what the red one is, but we can find the 2 yellow sides just by counting. Right? So say that we start here at this bottom point. Now, how far did we rise? Well, we went up 1, 2, 3 units. So that side of the triangle will be represented with a number 3. It's 3 units tall. And then as we go right and left, we're going over 1, 2, 3, 4 units. So that side length has a length of 4. Now, some of you may look at this and recognize it's a Pythagorean triple. It is a 3, 4, 5 special right triangle. Do you remember Pythagorean triples? No. Okay. We did that in geometry. Okay. That's fine. So say that we did recognize it was a Pythagorean triple, then we would know the red side was 5 automatically. If we don't, we just use the Pythagorean theorem. Now, it doesn't matter which one I choose as A and which one I choose as B, as long as I make sure the hypotenuse is C. So in this problem, I'm going to let 3 be A. So that's going to be 3 squared plus B squared. That means 4 is B, is equal to the missing side, the hypotenuse squared. 3 squared is 9, 4 squared is 16, equals C squared. That says 25 is C squared. We take a square root of both sides, and that tells me that the hypotenuse is equal to 5. Now, one thing I do want to point out here early on in this course is that anytime we are creating a square root, so we were trying to solve this equation, and we decided we needed to take a square root of both sides. Anytime we are making the square root, we have to always consider the plus or minus option, because it could be either one. It could be positive or negative. Now, in this particular case, we are dealing with distance, and distance is always positive. So we can eliminate the negative option and say that C is 5. But in general, in this course, when you create a square root, you cannot assume that it's the positive. You have to take both into account. Okay, so now let's say in general that I just had 2 points, and I didn't know what their values were. Like in the last problem, we knew that we were looking at the points 5, 6, and 1, 3. Okay, but say I don't know what those values are. Say I just know I have a point here, and I have another point here, and I want to know the distance between those 2 points. Okay, we're going to name the points arbitrarily because we don't really know what the values are. So I'm going to say that this point here is the point x1, y1, which then means I'm going to call the other point x2, y2. Now think about how we worked that last problem. We were looking for the hypotenuse, or the distance directly between those 2 points. And the way we got there was we formed a right triangle and we used the Pythagorean theorem. Okay, we're going to do that same thing here, except we don't really know what the values are. So let's first start with this side length. Okay, how could I find that missing side length? Well, before we could count, right? But I don't know what that value is. So how could you find a distance between 2 points? Well, think about, for instance, you were looking at people's height. And say you knew that someone was 6 feet 3 inches tall, and you knew someone else was 6 feet 8 inches tall. And I ask you, what's the difference in their height? What would you tell me? It's 5 inches. How did you get 5 inches? You subtract, right? You take your 2 values and you subtract them to find the difference. Same thing's going to happen here. Think about your 2 values. We are rising here, so that deals with the y value. So what is my greatest y value? It is y2. I don't know what it is, but I'm calling it y2. What is my lowest y value? y1. So what would this distance be between the 2? Well, think about before. We did 6, 8 minus 6, 3. So all we're going to do here is say that that distance is y2 minus y1. Very good. Now, horizontally, think about it the exact same way. My farthest x value is x2. My original is x1. So that distance there is x2 minus x1. Does everybody see where that's coming from? And now let's say that I'm looking for the hypotenuse, which is just the distance between the 2 points, right? So I'm going to use the variable d to say I'm looking for that distance. So now plug this into the Pythagorean theorem. So give me just a second here to clear this side of the screen and give me enough room. Okay, good. Now, the Pythagorean theorem says a squared plus b squared equals c squared. Now here, I'm going to let my a be this side length. Okay, it doesn't matter which is which. I'm going to call this one a. So my a value is x2 minus x1 squared. Plus, my b value is y2 minus y1. And that has to be squared because of the formula. And I'm going to say that's equal to the hypotenuse squared, which I have decided to call D. So that's going to be equal to D squared. Now, what is it we're looking for? We want to know the distance D. So what would I need to do to solve for D? Right now it's being squared. How do you undo squaring something? Take the square root. So I'm going to take the square root of both sides. And I'm also going to rotate this equation around. Okay, so I'm going to write the D first. So that says that D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, does that look familiar to anyone? Okay, that is the distance formula, and that's how it is derived. We use the Pythagorean theorem with two arbitrary points, x1, y1, x2, y2, and we plug them into the Pythagorean theorem to find what the distance must be. So this here is the distance formula. You may want to write it down. You're going to have to know how to use this, and you're going to have it memorized for the test. Now, I'm not going to make you prove this and show me how to get it, but you should have a general idea of where the distance formula comes from. Okay, so now I'm looking at page 5 and page 6. It tells me to look over at figure 13, that is at the top of page 6, and find the distance between those 2 points. Okay, so here's my drawing. Now it gives me the 2 points, and it gives me the line drawn there. Now I could go through and make a right triangle and do the Pythagorean theorem, but there's no need anymore. I know just to find the distance between 2 points, I can use the distance formula. Okay, so I just have to assign one of them to be x1 and y1, one of my ordered pairs, and assign the other one to be x2 and y2. So I'm going to pick this one up top to be x1 and y1. I'm going to let this one down here be x2 and y2. Okay, once you do that, you just plug into the formula. So the distance is equal to the square root of x2, which is 3, minus x1, which is negative 4. Minus negative 4 is plus 4. That's squared. Plus y2, just 2, minus y1, that's 5, squared. Simplifying that, that's going to be 7 squared plus negative 3 squared. And then I got to take the square root of that. That gives the square root of 49 plus 9, which is radical 58. And now your calculator can reduce that if it is reducible. In this case, it's not. So the square root of 58, or radical 58, is the distance between those 2 points. And that's my final answer. Okay, going on now to example 4. This one has 4 parts to it, so this problem will take a little time. But it says, consider the 3 points listed, A, B, and C. First, I need to plot every point and make a triangle. So let's do that first. It tells me A is at negative 2, 1. So I'm going to start the origin, go left 2, up 1. There we go. There's my first point. It's hard to get exactly with your finger. All right. And now make sure we name this point. Okay, that's something that I sometimes forget, but it's very important to do. So we'll name this point A. All right, B is at 2, 3. So I'm starting at the origin. I'm going to go right 2, and I'm going to go up 3. This gets me to right there. And then again, label your point. This is the point B. Okay, then same thing for C, starting at the origin. Go right 3, go up 1, which gets us to, I got the wrong size. There we go, that's close. And we're going to call this point C. All right, now first it says to plot them and make the triangle. So my triangle is formed just by connecting the 3 points. So there we go. There's my triangle ABC. Now B part tells me to find the length of each side of the triangle. Now there's one side that's easier to find than the others. We could use the distance formula for all the sides if we wanted to. But notice side AC. It's exactly a horizontal line, right? It goes right along that coordinate plane. So all I have to do to find the length of AC is count. So we start at A, count over to C, and we'll see that that side is 5 units across. So side AC is 5. Okay, now let's find side length AB. So it's got 2 points, A and B. They're listed up there in the problem. And we just have to use the distance formula to find the distance there. So I'm going to say that the distance between A and B is the square root of x2 minus x1 squared plus y2, 3, minus y1, which is 1 squared. All right, so I let B be my x2 and y2. I let A be my x1, y1. All right, then we plug that, or we just simplify that throughout. That gives me 4 squared plus 2 squared, which is equal to the square root of 20, which reduces to be 2 radical 5. Okay, so my length AB is 2 radical 5. Any questions there? Now, let's do the same thing for side BC. All right, so the distance is the square root. And again, I'm going to let this be x2, y2. And I'm going to let this be x1, y1. So I've got x2 minus x1 squared plus y2 minus y1 squared. So that's going to give me 1 squared plus negative 2 squared. And I'll let you simplify that out. I don't really have room. If you do, that turns into radical 5. Okay, so side BC is going to be the square root of 5. So now I've found the length of each side of my triangle. Any questions about that? C part tells me to verify that this is indeed a right triangle. So how might we go about doing that? How could I prove that this was a right triangle? Very good. We know the Pythagorean theorem is true when I have a right triangle. Well, the converse of that is also true, which means if the Pythagorean theorem works, then it has to be a right triangle. So the Pythagorean theorem again, it doesn't matter which side is A or B, but I have to make sure my longest side is C, the hypotenuse. So out of the 3 sides, which one is the longest? And how do you know it's 5? You're correct, but how do you know 5 is the longest? Well, what is 2 radical 5? What's the number for 2 radical 5? Like, how do you know it's longer? Because it looks like it? Okay, but 2 radical 5 can be written as a decimal number, right? And your calculator can do that. You can convert 2 radical 5. It's 4.5. Okay, so it's a little bit shorter than 5. And you can do the same for radical 5, and you'll get 2 point something. 2.2. So you know 5 is the longest side then. Just make sure you don't always look at the graph and say it looks like it, because sometimes that can be misleading, and sometimes the graphs aren't to scale. So make sure you prove it, and you know that it's definitely the longest side. So if 5 is the longest side, it must be C. So I'm going to plug it in there for C. And I'm going to let the other 2 sides be A and B. So I'm going to say A is the square root of 5, and that's squared, plus B is 2 radical 5, and that has to be squared. Now, if this is true, that means that it is a right triangle. So now simplify that. The square root of 5 squared will square root and square inverse operations. So that goes away. We're left with 5 plus 2 radical 5 squared is 4 times 5, which is equal to 5 squared. That simplifies to be 25. Okay, so what does that simplify to be? That's 5 plus 20 equals 25, which is a true statement. 25 equals 25. So since the Pythagorean theorem was true, that means this is a right triangle. Okay, and then the last one is D. D tells me to find the area of the triangle. How can I find the area of a triangle? What's the formula? Does anybody remember? Very good. Area of a triangle is 1/2 the base times the height. Okay, so to be the area formula, 1/2 base times height, the only side that we do not use is the hypotenuse. So again, in this particular case, the side AC is the hypotenuse, which means AB and side BC are my base and height, and it doesn't matter which one you choose as which. So I'm going to say the area is equal to 1/2 the base. I'm going to say my base is side BC, which is square root of 5, times the height. So the height of the triangle is 2 radical 5. Multiplying that, radical 5 times radical 5 is 5. And then 1/2 times 2 is 1. Okay, so my area here is 5. And I don't know what my units are, but I know they have to be squared to be an area. So I'm going to say that my area is 5 square units. Okay, the next thing we're going to look at here is the midpoint formula. So when you hear midpoint, I mean, what do you think the midpoint is? It's the middle of two other points, right? Now, where do we use midpoint in other places in math? Maybe we don't use that term, but think about finding the middle of something. With what? Mean, median, and mode, right? Those are all measures of central tendency. And think about how we find the mean. We add up all of the values and divide by how many values there were. Now that's the same thing here with midpoint. You're going to be given 2 points. So you're going to have 2 x's and 2 y's. Well, to find the middle of the x's, you add the 2 x's and divide by 2. To find the middle of the 2 y's, you add the 2 y's and you divide by 2. So it works very similar to the way a mean works. And again, this is another formula you need to have memorized for the test. Okay, so here's example 5. It gives me 2 points, and it tells me to plot the points and find their midpoint. Okay, so first let's plot those 2 points. That shouldn't be that difficult to do. So P1 is at -5, 5. So we're going left 5, we're going up 5. And that gets us right there. And then P2 is right 3, up 1, there. And I'm going to go back and name those points. So this one was P1, this one is P2. Now let's go ahead and find our midpoint. Okay, so what are my 2x values? They are -5 and 3. So you add the 2x values, it's -2, divide by 2, that gives us -1. And do the same for the y's. My 2 y values are 5 and 1. So we add those and get 6, divide by 2, that leaves us with 3. So the midpoint is at -1, 3. The way that, and then we just go and graph that, right? It tells us to plot their midpoint. So I'm going to go left 1, I'm going to go up 3, And right there, that point would be the midpoint. And you can see just by looking that it is in the middle of the other 2 points. If you look at your graph and it doesn't look anywhere close, then no, you've probably messed up somewhere.